If you look at what was invented by Bitcoin originally, it was this concept of digital trust and the ability for computers to be able to reach consensus on something. In the case of Bitcoin, it was about money. It was consensus about balances, payments, and transactions. This allows us to build incentive mechanisms for markets that could not really exist before. A decentralized means by which we can incentivize participation and maintenance of the network. The Bitcoin network is by far the largest aggregation of computing power in the world, and is itself a marketplace for that computing power. With Bitcoin, you have proof of work. Proof of work, in a nutshell, involves effectively guessing a random number that fits a particular pattern. It's a lottery as to who gets to fill the transactions in the next block on the network, which is called mining. All of the miners around the world go about solving this puzzle. When they solve it, the rewards go to the miner that solved the block, and the rest of all of that effort is basically discarded. It's wasted. With proof of work, the effort that has gone into everything that's done is a means to an end, but in and of itself has no value. This hashing mechanism that all of these computers around the world, filling data centers, burning through vast amounts of energy are doing, does not have any value in and of itself. It's a means to an end. But what if there was a way that we could take that mechanism, that incentive, and build a blockchain marketplace where all of that work did have value? Rather than wasting it, what if it was actually going towards something useful? What if we could apply that same concept of a decentralized, incentivized, permissioned network to machine learning? That's what Zenqira is. Zenqira leverages the same innovation that brought us consensus on things like Bitcoin, but it brings it to what we deem the most important thing in this fourth industrial age we are going through, which is machine intelligence and machine knowledge. The hash function in Bitcoin is a very concrete function. It simply finds bytes that match a particular pattern. The consensus mechanism of Zenqira has to deal with a far more fuzzy set of outcomes. It has to evaluate knowledge. If I ask everybody here in this room to take, say, a paragraph or a page of Shakespeare and summarize it down to a few sentences, everybody here would come back with something slightly different based on their understanding. The question then is, how do we evaluate which is the best summarization of that data? How do we work out which one of those participants should be rewarded and how much they should be rewarded for their effort? That's what the consensus mechanism in Zenqira does. It looks at the decentralized network, with each participant contributing intelligence and knowledge to the network, and they are rewarded in accordance to how well they are providing that information. In the same way, if I were to reward people here for how well they could summarize Shakespeare, hopefully that would incentivize people to learn more about Shakespeare to get a better summary and a better reward. So we're building a massive decentralized neural network aimed at better understanding the information in the world around us. Currently, the industry is dominated by a number of large players like Meta, formerly Facebook, Microsoft, Google, and Uber. These companies have dedicated AI teams working on big algorithms, but these institutions are doing it in a very siloed way. They seek the computational power of, say, Bitcoin, but they're doing it in the wrong substrate. They're building huge centralized data centers to process this and to run their models. What if, instead of solving these machine learning problems with big centralized supercomputers, we leveraged every computer available on the internet? That's what Bitcoin showed us. The compute power of the Bitcoin network is greater than the top 500 supercomputers combined. The scale that we could possibly reach with such a network would mean we'd have a lot more availability to train much larger data sets.